machine learning as well. So the aim of this project was to create a submodule to make that allows circuits made in Qiskit to be run on QuTiP-QiP simulators. So what it did was it took circuits made in Qiskit, converted it to QuTiP circuits, and then these converted circuits were run on whatever choice of simulator. So like the final usable thing was like two backends. One was Qiskit circuit simulator, which is just based on QuTiP-QiP's gate level circuit simulator, and the other one was the pulse simulator, which took like a circuit from Qiskit and converted it into QuTiP circuit, and then simulated it on these QuTiP-QiP's processor models, which like the special part of that is that it supports noise. So yeah, in this backend, like these three processor models were supported. So yeah, I'll show a demo of this. So in like usually this is how you make a circuit in Qiskit, and then this is how you run it. Like this AER simulator is one such backend, which is provided by Qiskit itself. So after defining a backend, we run it, and then we can see the results using this function from Qiskit. So in this like project, the point was to kind of provide this interface for simulating in the same way as Qiskit does. So here, so using QuTiP, the interface is similar. We define a backend. Now this is the gate level QuTiP simulator, and now we can run this circuit that was defined in Qiskit on it and get the results in the same way that we get from Qiskit. So yeah, this was like an example of it. So like what is like the use of running Qiskit circuits on QuTiP-QiP backends rather than like using any other backends? So like this purely depends on the use case. Like for example, QuTiP-QiP provides like a really good interface for supplying noise to the circuits and like simulating noisy devices. So like that is one big use case in which you would specifically use QuTiP-QiP. And in general, like different backends, like even including the non QuTiP ones, like provide different functionality, and like it might prove very useful to like be able to simulate circuits on these different kinds of backends. And like another thing is like why would you make the circuits in Qiskit rather than QuTiP itself? So like this also depends on use case, but in general, like Qiskit is focused on making the circuit creation like better and more powerful, and it also like does some gate level optimization. So in like sometimes it might prove very useful to like make a circuit in Qiskit and then simulate it using QuTiP-QiP rather than like making it in QuTiP itself. So yeah, that is one thing. So yeah, I'll show another example where we like provide the noise and then simulate the circuit. So this is the same circuit as before, hard-marred on the 2 bits. So in for simulating using the processor models, we define the processor. This is QuTiP-QiP's like this is QuTiP-QiP's interface for defining the processor. Here we have provided some noise. With this is amplitude damping noise, and so yeah, now we run the thing in the same way. In the pulse processor, we provide the processor as an argument. So we can mess around with this any way we want and just provide it as an argument, and whatever the simulation will be according to this. So yeah, this is like the plotted thing of the final result. And yeah, as you can see, like the noise has taken effect. And another thing is like you can even get the final density matrix at the end of the simulation. So yeah, you can use it for whatever. So yeah, and so yeah, that was like a summary of what the project was and what it does. So like finally, I'll just talk about like some scope for additions to this project. So as I said, like these three processor models were supported in the pulse simulator, and these two are still not supported and like can be added. So that is one major thing that can be added to this project. And another thing is like Qiskit also supports like making circuits using pulses directly. So we can make those in Qiskit and then add support to run these directly on the QuTiP-QiP processors instead of like converting the gate level circuit. So that is another major thing. And another thing was like the pulse processors don't support in between measurements. Like by default, all measurements are done at the end and the results are shown. So this also can be added. Like other than that, of course, like any issues or anything that the community like points out, like that can be added. So yeah, like thanks a lot to my mentors for their help and also to Nathan for all the support. Yeah, I'll end it here. Any questions?
Yeah, thank you very much, Shreyas. Do we have any questions?
I have a question. So, if there is something that Qiskit does and we do not support in QuTiP, what happens? Like, is there, for example, some mid-circuit measurement? I know that QuTiP-QiP probably we don't have mid-circuit measurements yet. So what handling those kind of things?
Yeah, so one is the measurement support that I mentioned that should be added. And another such, like in general, like it would throw an error if anything is not supported in QuTiP. That is being actually added to the circuit in Qiskit. So it would throw an error. So like two cases of this were, one is the measurements and another one is like user-defined circuits. So in Qiskit, you can like actually define circuits on your so yeah, like another thing other than this measurement was like user-defined gates. So you can define user-defined gates in Qiskit, and some of them will like fail while doing this QuTiP simulation. I've tried to like provide support for some of these user-defined things, but all of them won't work. So even that needs to be added. And I guess some other things that I'm not aware of right now, like which might be pointed out later. So yeah, these need to be added. Otherwise, like an error will be thrown.
Thanks.
Which user-defined gates do you support?
Sorry.
Like which, so like I guess because you were saying before that you don't support user-defined circuits. So did you mean that you don't support certain user-defined gates?
Okay, so what is supported right now is like, so if there is a gate that is not there in like, so right now how I'm converting the gates is like there is a map of like some native gates in Qiskit, and these are mapped to like the native gates in QuTiP. So like if any gate does not fall in this map, its unitary is used to like calculate a custom gate in QuTiP, and that is like that is used in the circuit. There is also like an option to toggle this on and off if the user does not want it. So anything that does not fall in this category is like yeah, then it throws an error.
I see. Okay, thank you.
Add a short comment on this. So it actually depends on what kind of simulation you are doing at the QuTiP side. So if you are just doing circuit unitary, like a unitary circuit simulation, you multiply gates to the state, then as long as you define that custom gate with the unitary in Qiskit, then we can handle this. Now, this is different if you now use, as what Shreyas just showed, like those processor models, which actually simulate the circuit at a Hamiltonian level. Then that's different because there are gates defined in Qiskit that we don't support because it's not implemented in the physical model. There's no pulse associated to that. There are also gate QuTiP that is not supported by Qiskit, or it's not naturally supported by Qiskit. Like maybe some gates associated to spin exchange. So there are this thing in both directions.
That makes sense. Thanks. Yeah, I think what prompted my question was, I think Shreyas had said that it didn't support user-defined circuits, but I think he meant user-defined gates. Some user-defined gates. Okay, thanks.
Shreyas and Foxy, if you can hear me, I also have a question, which is just, what is the best way for, or do we have a good way for people to learn how to use this really awesome supporting QIP for executing circuits on different systems? It was something which I think was really interesting to the students that Alex and I spoke to at Kigali during the summer school, but I'm not quite sure how to show people how awesome this stuff is and get them using it.
Sorry, could you clarify on that? I didn't get your question. Like, do you mean like how you can in general make Qiskit backends, or like this specific interface, like how you use it?
I think Simon's asking, are we pointing people towards documentation, or do we have examples available that people can reference?
Right. Okay, so in the QuTiP-QiP documentation, there is a user guide added for this. Can I send a link here, like which channel do I use? Call chat.
Yes, you can.
Yes,
yeah, you can
chat.
send the link to the community call.
There are
Yeah.
examples in the documentation associated to this. But this is note that this is not in the released version of QuTiP-QiP. You have to clone the GitHub and install that yourself. And in the documentation, in the latest documentation, instead of the stable one, you will see that, because this is very, very new and hasn't been released yet.
Right.
Awesome. Thank you. Okay, let's move to the next person. Go ahead.
Okay. In which case, then, Eric, perhaps you might want to say a couple of words about where this project idea came from, and then we'll hear from Xavier.
Okay. Well, QuTiP, we had Bedmark working with QuTiP, I believe, version 3, 8 years ago, which since then were never updated. Were just left abandoned in a repository on GitHub. And having QuTiP, having benchmark will be really useful, since we make big change. We introduce new way to do matrix operation. We introduce new solver, and we want to know if our work is working. So we needed benchmark. So we proposed a project to update these very old benchmark and pretty much redo them from the ground up at today's standard. And this is what Xavier did this summer.
So my project this summer was to create the benchmarks for QuTiP's main operations and solvers. So as Eric said, the main goal was to replace the previous set of benchmarks, but there was ultimately two different objectives. The first one was to create two separate types of benchmarks. So the historical benchmarks, which would effectively track the performance over time, and then scaling benchmarks, which would basically allow us to compare different solvers or different versions of, say, a multiplier for matrix multipliers, different data backends, to see which data backend or which solver is more effective at which matrix size. And then the second objective, which was more of a problem, was figuring out how to create these benchmarks without too much noise. Because on any machine, if you create benchmarks or run them, there'll be a certain amount of noise due to the amount of data that's in memory or applications running in the background. And this is even worse when you do it on a virtual machine, which is what is done here, since we're using GitHub Actions to run the automatic benchmarks. So the first solution, the first part of the project was spent testing whether running the benchmarks in GitHub Actions produced too much noise to be able to plot data that would be useful. And the result was that ultimately GitHub Actions allows us to use 5 different processes, but they're allocated at random. So what happened is I first tested to graph regardless of what processor was used, which produced way too much noise. So we decided to try and separate it by processor. And so that's what's plotted here. We can see I've chosen for the QuTiP benchmark website, we've chosen the 3 most stable and performant processors that GitHub Action uses. And as we can see here, since there hasn't been too much changes to the library yet, the graphs are fairly stable and the noise is not too much present. And we can clearly see the difference in performance between each processor. So in this case, the dotted lines, the solid line, and the dashed line are the 3 different processors. And the different colors are which data backend is being used. So far, the benchmarks that we are producing are for the addition of 2 matrices. So using a NumPy, SciPy, QuTiP-Dense, and QuTiP-CSR backends. The matrix multiplication, so operator multiplied by operator and operator multiplied by get. We're also benchmarking multiplication for QObj-EVO. And finally, different solvers. So we're currently doing the master equation solver, steady state solver on the website, and available for users to download. There is also a solver on the Monte Carlo solver. And second, so these are the historical benchmarks. So we can see that they started on the 15th of September, and the last benchmark that was done yesterday. And so this allows us to track the performance of our code over time, so throughout updates, and check whether any major update either breaks the code or causes major slowdown or major speed up. Second, we have.
Could you maybe zoom in on one of them, because I can't really see. Is that possible? Okay.
Yeah.
Yeah, that's great. Thanks. Okay.
All right. So actually, I'm going to change to the scaling. Let's just do scaling operation. And so these are our scaling benchmarks. So this is based on the size of the matrix that represents our quantum system. So if it's an n by n matrix, in this case, we have 2 logarithmic scales. And we separate by density of the matrix. So we have a sparse matrix with, I think it's 20% density, and then the dense matrix that's basically at 100% density. And we can see the different performance of the different data backends. So for example, if we have a sparse and we use the matrix multiplication, up to about 10, matrix size of 10, NumPy is still by far still the fastest, but it quickly gets very slow. And we can see here that the QuTiP CSR backend, which is based off of the SciPy CSR backend, is a lot faster, which is ultimately what's needed, since this is the QuTiP backend that's developed specifically for operations. So these are effectively the benchmarks that are run on a nightly basis on GitHub Actions. So these benchmarks here are effectively taken from the latest benchmark data, whereas these ones use all the different benchmark data that's been since the beginning. So in this case, the 15th of September is when it's started. The package also comes with the ability to create your own benchmarks on your own laptop if you download it and connect to your PC. So you have the installation, you can just do git install. And then you're provided with certain flags that allow you to run a default style of benchmarks. So here we have the command that you can use to run the benchmarks. This collect only flag allows you to see which are all the available operations and solvers, as well as matrix sizes available to benchmark. And then the main function is to be able to view the benchmarks and allow you to sort through and filter through the data, so you can only plot images of the benchmarks that you want to benchmark, that you want to view. So if you do, for instance, if you have a benchmark file that contains every single operation, but you only want to plot the operation add, you can use this function available to filter out all the other operations and only plot the relevant data. So I can go through, I can demonstrate. I had a tutorial, but sadly it broke, which is why I was a bit late and I didn't manage to fix it. So I'm going to use a markdown file that I have already uploaded to the GitHub that's available for everyone to see, which runs with a few test benchmark data. So maybe I should go through the JSON file first, which shows what sort of data is saved, so that if you want to run benchmarks and then create your own visualization tool, you can see what effectively is taken. And this also allows us to see what can be used to update the program later on. So we get all the information about the CPU, the Python version, etc. So all the hardware that was used when running. The commit information, the latest commit that's being used to run the benchmark. This is, and then we have the different operations and the parameters that are used. So in this case, this is the data for the NumPy backend of a matrix of size 2. This is the dense type of matrix, and it's effectively the add operation. And then we have the statistics with the thing. It's run 100 times, where actually it says so somewhere, iterations. Oh no, I've set it to run only a single time. So you have all the different information for each single benchmark, and then you can add them up to create your plots. So this is what I do here. we first create a data frame with all the information from all the different files, since there is one file per daily benchmark, which contains the main information that we need to use to plot. So in this case, the CPU, the time, and the different parameters that define what kind of information is available. So this is the whole data frame, and we can then...
I'm still only seeing the QuTiP benchmarking web page.
Wait. That's... I need to change... Okay, I thought I was sharing my second monitor, but I'm apparently only sharing a window.
That's not just me.
Stop streaming. Share my screen again, and...
Oh, and for the end, there's some questions in the chat, but maybe just leave those for the...
Yeah,
okay,
I'll
great.
keep them for the end.
Now.
All right, so I'll take a look at the questions later. So this is effectively, so this is what the JSON file looked like that I was talking about earlier, with initially the machine information, and then the benchmark information and the commit information. And this is a walkthrough that's available on the GitHub of an example usage of the different methods that we can use to sort through the data that's available in all these files. So one of the first effectively create data frame methods allows us to create an entire data frame with all of the data put together, and we can then use different methods to filter and sort through all this data. So for example, here I'm choosing to only visualize these specific operations. So I use sort ops, and I create a small list with the operation names that I can then pass as parameters. And effectively, it sorts and filters out all the data available. And after this is sorted through operations. Then we can sort through parameters. And finally, the results from this are passed on to the plotting function, which then creates the plots that you saw on the website. So now, if I go back to the website again, so I have to stop streaming this, share the screen again. There we go. So that's for what is currently up and running. There are some updates that still need to be done for the code. Notably, being able to run scaling benchmarks not on matrix size but on matrix density. So right now they're only defined as dense and sparse. It would be probably a good idea to be able to, rather than having solely sparse and dense, just have a scaling from 0 sparsity to, 0 density to 100% density. And we could then compare the data backends more accurately based on the density of the matrices. And then potentially update slightly the website, especially the front page, which currently is very bare. And I have had messages from QuTiP members thinking that it was broken because of this. So I'm currently working on creating just a front page that looks nice, and that also explains notably the different models for the solvers being used, because you can see here there's a Jaynes-Cummings model, a cavity, and a qubit spin chain, which are effectively a very sparse model and then slightly more dense models that are then being shown in the different benchmarks. And I think that's it for me. So I'll go through the questions that are in the chat.
Nice.
So I think the first question is from SysData. Are all of these benchmarks for CPU? Yeah, all the benchmarks currently are for CPU. That is actually one of the other updates, is to be able to add the support for GPU benchmarks. But since the GitHub Actions doesn't run with a GPU, I believe, we can't do the daily benchmarks. But the idea is to be able to add that to the scaling benchmarks, so that someone can then download it to their own machine, and based on what kind of GPU they have and CPU they have, they'll have different results as to what is more effective. I initially had some GPU, so the QPy methods when I was testing, but I removed them and I haven't re-added them since.
Wouldn't it kind of make sense to have like a dedicated workstation that, you know, some university sort of buys and that just sort of runs these things sort of continuously?
Yes. But I'm not in control of such things.
But I mean, there's like a couple of groups, I guess, that sort of support QuTiP in some way. And
yeah, it would definitely make sense. Yeah, to have a dedicated workstation.
Yeah, now that we have the benchmark suite written, I'd like to run the benchmark suite on a machine at Ricken, like run the nightlies on a single machine at Ricken, and just add that to the plots, or make some separate plots, so that we have a stable single machine. It was also very interesting to see how far you can get with just the GitHub Actions machines. I was quite surprised how well that turned out. But yeah, running on a stable machine would probably be really good. But it's also good to know how things work on, I guess, the kind of generic processes out there. And the problem with these stable machines is that five years later, you have a 5-year-old CPU. Anyway, but yeah, this would be good.
And then your question, Michael, yeah, the matrices and CAD are generated randomly. They are Hermitian, and they're generated using the default random QuTiP methods. So it's QuTiP rand herm, I believe, and rand herm ket. And then Simon answered Andrea's question.
Thanks very much for your excellent project and for presenting it to us. Yeah, it looks very exciting. So, thank you.
Thank you.
I think maybe it's time to move on to the next speaker. And so I guess maybe Christian could go next, and perhaps Simon, you could start with a sort of brief introduction to where the idea for the project came from, and then Christian can tell us about his project.
Sure. So a lot of people, QuTiP has a very nice set of tutorials, which are a lot of our users' first interaction points with QuTiP. But the tutorials were made after many years, and the team who looks after QuTiP is comparatively small compared to the number of tutorials. And so a lot of them had gotten out of date, or just, and were no longer up to date with the latest version of QuTiP. Or just maybe they worked, but they used old idioms. And so I wanted to have some way to ensure that to get the tutorials up to date, but then also to ensure that they stayed up to date and stayed a really kind of awesome resource for our users, and actually also for ourselves to see how to do things, and to make sure they always work with the latest version of the code. And Christian we actually had a few different users come to us and go, the QuTiP, some tutorials are no longer working, and I was immediately able to point them to Christian's work and say, they're aware of it, and in the meantime, here's one that's already fixed for you. Anyway, Christian, take it away.
Okay, so let's start then. So I worked on QuTiP tutorial refurbishment. So you can go to the next slide. So I will talk about tutorials in QuTiP basically, and what their status was before my GSoC project, and then kind of say what I did in my GSoC project. And in QuTiP, like the tutorials are mostly Jupyter notebooks. So I will talk about how to use them with Git, GitHub Actions, and also tell you about some DevOps tools to use with Jupyter notebooks. So it's more a talk about the ecosystem around the tutorials rather than actual enhancement of QuTiP, or it is an enhancement of QuTiP. Okay, so next slide. So currently there's a repository that's called QuTiP Notebooks, which basically collects all tutorials on QuTiP, and it built up over many years, and there's around 100 notebooks. And yeah, there's about 30 contributors to that repository, so just a huge notebook repository. And then there's a tutorials website, which is the main learning source for QuTiP, and it has these hard-coded links to notebooks and this GitHub repository, and also categorizes these notebooks. So if you're a new user, you go to the website and look for the stuff that you're looking for. You can download the notebook from there. Yeah, that's fine. Good. We can go to the next one. So this notebook repository, that's like many tutorials are edited a few years ago. So actually they're not working anymore with the current release of QuTiP because they were just not made for this current release. So they're not automatically tested to check if they're still running or not for the current release, and also not for the upcoming release. And also these notebooks sometimes just look like a Python script, so you don't really use the Jupyter Notebook Markdown tool to kind of add some documentation to it, so which makes it difficult for new users to get used to QuTiP, because you just have this Python script to start with and not like a nicely marked down notebook. Okay, go to the next slide. Seems like Alex can't hear me anymore, but at least Xavier hears me, yeah. So the project goals for GSoC were that I want to rework these tutorials so in a way that they always work and that they are somewhat understandable to new users. Also that they're compatible with the upcoming release, which is QuTiP-QiP. And with that, like making it compatible with that release, we also wanted to find and fix bugs in QuTiP-QiP, and also want to add this infrastructure around the tutorials to like automatically do all these things, checking that the tutorials still work. Yeah, so can we go to the next slide? So how you do that usually is building up a CI/CD pipeline with GitHub Actions. So you just put in some code, which then checks that the code size is correct, performs some tests, and then publish it. So now here the difference is that you input Jupyter notebooks, which makes everything a bit more difficult. And we'll talk about the tools that we use to build up this pipeline. Okay. So the first thing is, if you ever worked with Jupyter notebooks and Git, you will have noticed that there happens this thing that you have like huge diffs because of all the metadata in the notebooks contain themselves. So, it makes it really hard to review changes in like tutorials or notebooks because they're just hidden under all this metadata. Yeah, you can go next slide. So for example, here there's like versions and NV format minor, I don't know what that is, and then some other metadata. So it's difficult to review these IPython notebooks, but there's a tool called QuiTiP-QiP to kind of convert these notebooks to markdown files, and then you can which just contain the source code, so you can actually nicely review changes, and yeah, you don't have all the output from these files in Git, which makes it much easier to use. Yeah. So then about formatting, usually in Python you use this PIP8 style, and you use tools like flag, isort, or flag8 to make your life easier to conform with the code style. Jupyter Notebook's not that easy, but there's a tool called Notebook Quality Assurance, NVQA, which allows us to apply all these tools to notebooks. And yeah, I found that really helpful with that. So then about testing, so QuTiP actually uses PyTests, which is nice. And I mean, QuTiP has a lot of tests, but we also want to ensure that tutorials run without errors. And now you have to throw in a Jupyter Notebook into PyTests, and there's actually a nice plugin for that, which is called nvmake, and then you just which then just checks if all cells in the notebook itself are executed without errors. And then there's another thing about testing on the next slide. So I also added like new cells to each notebook that check the calculated results against some analytical results or results from another solver or something to check if the outputs of the tutorial are actually correct. And in this way, it kind of adds additional tests to QuTiP. So like integration tests, because these tutorials are basically using a lot of QuTiP functionality, and then in the end, it checks if the outputs are correct. And then the last step in this pipeline was publishing. So I created a template for the tutorials website, and then the script that just inserts links to all these notebooks. So to all notebooks that are now working with the current and the upcoming release in this new repository. And since QuTiP uses GitHub Pages, it was pretty easy to use GitHub Pages import tool and then directly publish this HTML file that's created from the template and the script. So with that, you have like this full CI/CD pipeline done. Next slide. Which runs, so this pipeline runs for every new tutorial, so only tutorials that pass all these formatting and tests are actually published on the website, and not, so you don't have any not running tutorials on that website anymore. And there are also these nightly runs of this pipeline, so if you change something in QuTiP and it breaks a tutorial, you will be notified at least by midnight that some tutorial is not working anymore. Which wasn't there before. So it does that automatically. So we can go to the next slide. So this is what the tutorials website looks like now. It just looks like before, if you've ever been on this website. So it just has these sections still, but everything's like inserted automatically. Before you had to go to the website and hard code your link into it if you added a new notebook, and now everything's done automatically by GitHub Actions. Go to the next. So actually the main part of my work was porting these notebooks from the old notebook repository, and then I applied like formatting, added some markdown, fixed some errors in the notebooks themselves, updated functions, and then also added these test cells I was talking about in the end of the notebooks, and then I just added it to this new notebook repository. And I did this to 60 out of these 100 notebooks, so mostly in the area of introduction to QuTiP, quantum information processing, and then the notebooks on time evolution solvers. And I did this port also for QuTiP-5, and I was able to find like 18 pull requests in QuTiP itself, like fixing bugs or adding also some functionality that was missing. So in summary, I kind of created this ecosystem around tutorials, which automates testing and publishing. It was also simplifying the contribution process. So now if you want to add a tutorial to it, you just add it to this repository. It tells you if it's running fine with all QuTiP releases and if it's nicely formatted and things like that. And then it also adds more tests to QuTiP and checks that all tutorials are still running. So yeah, as I said, I ported 60 tutorials for the current release. I also ported 50 for the QuTiP-5 release. And I think that improved the quality of the tutorials greatly, because now if a new user is coming and they don't have to go to the Google Help group anymore and say, I want to use this tutorial, but it's not working. That was kind of annoying when you just start learning about QuTiP. So I think this whole project made it a bit more fun to learn about QuTiP and not deal with some problems because they are outdated. Okay, yeah, and I think that's it. So yeah, thanks for this great summer project. Also special thanks to Simon and Neil for mentoring me. And yeah, the new QuTiP notebook or the new tutorial repository is called QuTiP Tutorials, which you find on GitHub now. Yeah, that's it. If you have any questions, let me know.
Well, Thank you very much, Christian. I'll echo what Simon's put in the chat. Looks like awesome work. And we throw open the floor to any questions.
One of the goals here is to ensure that all the notebooks are up to date. And you said that now we have a check that runs every day, so that if something went wrong, we will know it by midnight. Should we also try to include this into one of the pull request actions, so that we know this ready when you're opening a pull request? Like for example, QuTiP-QiP.
Yeah, I was talking about that with Simon. So first, we wanted to make this in keep everything in this QuTiP tutorials repository on this GitHub Actions. So the thing is, running like all notebooks takes quite some time, and I think if all notebooks are in there, it takes at least over an hour. So I'm not sure if you want to have that for a pull request, but
pretty long that's pretty long indeed.
Yeah, so I'm not sure if we want to do that. But I mean, it could definitely be done. And just copying basically this GitHub Actions file to the other repository, to the QuTiP repository, right?
Is there a way, for example, for QiP, I select a few notebooks that is related to QiP and only run those?
Yeah, sure. So right now, I just in the QuTiP tutorial, it's not repository itself. I just run it on every notebook that is contained. But you could also just filter QiP notebooks for sure. Yeah.
I think that's good.
Yeah. If you or if you want some help with that, I can definitely help you setting that up.
That's great. And is the tutorial on the website already partially replaced by this? Or that's
I opened a pull request on the website, or on the repository for the website. I'm not sure if it was merged yet, to be honest.
Okay.
I have to check, but I think it's just one click away from being like that.
That's great. Thank you.
Yeah.